Hey, this is Mr. Hansen. We're going to be looking at the midpoint formula today, and what we're going to do with that is we're going to try and prove why it works, and then you'll know that it works in every case. When you're given two endpoints with coordinates, you can always find the midpoint. And this will, once you have this understanding, you'll be able to generate or expand your knowledge to include partitioning a line segment up into equal thirds or fourths instead of just equal halves. So that's why we're kind of walking through this step by step to make sure you understand how it works the way it does. All right, let's get started. We have a diagram here, and we have some statements, and we're going to say why we can do what we can do for each of these statements. So first of all, the thing that we're trying to prove is this part right here. X2 plus X1 over 2 equals X midpoint. And this is a formula you've probably seen in 7th or 8th grade. But let's take a look and see what we can do. So statement number 1 says X2 minus X1 equals a horizontal distance. You can tell I've drawn this in red. X2 minus X1 equals that distance right there. And in this case, if X2 were 5 and X1 were 2, 5 minus 2 is 3. And that is a distance of 3. So hopefully you're seeing that. And the reason we can say this is the ruler postulate. Ruler postulate just says you subtract when you're finding the distance of a horizontal line segment. So ruler postulate. Okay, let's take a look at step number 2, X2 minus X1 divided by 2. So we're going to just take half of that. So I'm going to kind of, and you can see it just goes out about this much. There's half of it there, and if we kind of drew a vertical there, you can kind of see that it would meet at the midpoint there for the X coordinate. So half of the horizontal distance, and we're just dividing by 2. That's all we're doing, dividing by 2 to get half the distance. Okay, now so we've got this little black line segment. Step 3 says X2 minus X1 divided by 2 plus X1. So we're going to add this distance right here. This is X1. We're going to add that distance there. So we add those two things together, and then we get this whole from here all the way over to there, which is going to give us the X coordinate for the midpoint. So we're going to add those two things together to get the X midpoint. We could call this the segment addition postulate. Meaning you add two segments in a line together to get in a line segment to get the complete thing. Okay, number 4. Can you tell what we're doing from here to here? It looks like we're just factoring out that divide by 2 or that times by 1/2. We're just factoring that out right here to each part. So I'm just going to write factoring. Okay, and then to get from 4 to 5, what changed here is right there. We said X1, same thing as 2 divided by 2. So this is like got a coefficient of 1 right here. 1x1. 2 divided by 2 is the same thing as 1. So I guess we could call that anything divided by itself equals 1. I'm just going to write x over x always equals 1. Something like that. Okay, or let's just do this. 2 over 2 equals 1, the most specific way. Okay, let's take a look at number 6. Well, I don't know, maybe you're starting to figure out why we did that. We have to get a common denominator right here. That's what we're looking for. So in number 6, we actually added these two in number 5 together. So it's negative 1/2 x plus 2/2 x. So negative 1 plus 2 is just 1x right there, just 1x. So 5 to 6, we're just combining those like terms there. Combining like terms. And then from 6 to 7, it's kind of like we're taking this piece here and this 2 there, and we're kind of distributing it out, so it's 1/2 of x2 plus x1, so we can write it like we have it here in number 7. We just call it distribution. So the big idea based on the sketch here is that we started with the red line, we took half of the red line, and then we added this other part up front here to give us the x1 or the x midpoint value there. And you would do the same thing with the y. So here's you'd start with this line here, you'd take half of it, and then you'd add up that part there, and you'd end up right about there. You do the same thing with the y. And the reason why we're going through all of this proof is to help you understand how to, when we divide a line up into 3 parts instead of 2 equal parts, or into 4 or 5 parts, then it'll kind of make sense what we're doing here, and it'll help you understand how to do that. Hope this helped. Thank you.